Okay. Thank you. Oh, ada lagi yang baru masuk. So, apa yang 1 plus ni? How did I get this over here? Siapa yang baru masuk, please sign in your attendance on Putra Blast. It's from 8 to 9. So, jangan terlepas waktu dia lah. Okay. So, I am recording, right? Okay, yes. Okay, so last time, betul, okay. Last time we talked about QVB, F equals to QVB, but the scenario was that we talked about a charged particle that was moving, a charge that was moving, so it behaves like a current. Remember, magnetism can only happen when we have current. So the charge was moving, so okay, we assume that it is behaving like a current, so we could use this equation. Okay, so it was for a charge that is moving. Now, this is for today. We are not discussing about the charge, the single charge moving, but we are discussing in terms of a conductor. Okay, so here we have a length of conductor. So this is the difference between the two equations. This was for a charge that was moving charge, hence why we have the Q, right? So that's your biggest hint, I guess. Moving charge. And this equation is for conductor. So you have the L there, it's a length of conductor. So it has to be a wire lah, or a rod or something that has length. Okay, so that's the difference between the two, but both are magnetic force. Okay. Okay, so you know when we have a cross product, when we expand it, it becomes a sine theta. What is the sine theta? Sine theta, the angle between the length of the conductor and the magnetic field. So in this case, the length of the conductor is at first over here lah. Dia mula dia straight lah. There was no force. And the angle between the length of wire with the B, our B is here, right? Our length of wire is like this. So it is 90 degrees. So it is at maximum. So if I were to use this equation and expand it, I would say F equals to I, whatever the current is, whatever the length is, whatever the B is, and the sine will be sine 90 because my I is this way and my B is this way. And the angle between them is 90 degrees. Okay, so it's fairly straightforward, just like QVB. You have to know the angle between, in this case, it was the charge direction with the magnetic field. This one is with the length of wire with B. Okay, so moving on. The force is maximum when the direction of the current is perpendicular to that of the magnetic field. We know this already. Here we have the B in the form block. B in X. B rupa dia X. So we are looking at the butt of an arrow, which means that it is going into the page. And my I is this way. So it's 90 degrees lah. So we have a maximum. Siapa yang asyik message saya ni? Okay, so it's a maximum. Sine 90 is equal to 1. So the force is 0 when the direction of the current is parallel to that of the magnetic field. We know this already. So F equals to I L cross B. Banyak pula gangguan. L cross B, which means that this equation will be 0 if L and B is parallel. So always when you see a cross product, that is always the situation. It is trying to tell you, please avoid parallel situations because the equation will not hold. Okay. Okay, so here I talked about F for a conductor. So now kita nak tengok what happens. What is moving here? The force is down. What is down? Okay, I think dia nak discuss in general dulu lah before we talk about the actual movement. So here let's imagine ada something lah kat sini. Kita nak cakap the theory first. So here I have a battery plus minus. So the current flows from the positive to the negative. Okay, so now This guy is my current, and this is my, what do you call this, magnetic field. So magnetic field always goes from north to south. Just like electric field, it goes from positive to negative. For magnetic field, it goes from north to south. So that you already know when they give you a magnet like this, sometimes they don't draw the B for you, but they label it like this. N is here, south is here, and you have to determine what is your direction of magnetic field. So in this case, you should know that your B should go from north to south. So this is your B. You don't have to make it fancy like this, ada curve bagai semua. As long as you know the direction, it should go from north to south, you are fine. Okay, so that is your first thing that you need to understand. And then with that said, I have B. B goes from left to right. Right, after left to right. So my middle finger goes to the right. Saya terbalik dengan korang middle finger goes from left to right. My current goes into the page. My force is going down. As you can see, my thumb, I don't know if you can see it. My thumb is going down. So if there was, if I put something over here, macam nak buat? Well, if I had something there, like it would move downwards. The movement would go downwards because of the force. And then when I flip the direction of the current, now my current is moving this way. Previously, it was moving this way, the other way. So now my I is over here. My north and south is still the same. I did not flip the magnet. So it's still the same. The B is still the same. So again, using my right hand rule, B is to the right. My I is going out of the page, so my force is going up. Okay, so if I were to draw it, it would be like this. So this is my B, my I is going out. So this is my F. And if I were to draw it for this guy, my F is like this. This is my B. Everyone is at 90 degrees, right? It's like XYZ axis. Everyone is 90 degrees. Ni anggap 90 degrees lah, saya tak pandai nak lukis cantik-cantik. Okay. So, kita nak belajar direction je dulu. Nanti you will see how this works. So again, we have current flowing, we have magnetic field. You will get some force happening in the magnetic field. Kini dalam magnetic field. Dia tak adalah force tu tiba-tiba jadi dekat sini kan. Ni yang benda ada I je. You don't have B. So it won't work. You have to have the I and the B for force to happen. Jangan randomly lukis force dekat mana-mana Kena ada magnetic field and I. Okay, so a straight wire carries a current of 5 ampere. Okay, so we have I, straight wire, 5A. Magnetic field is uniform, great. B is equal to 2 times 10 to the minus 3 Tesla. The wire makes an angle. The wire, which means that we are talking about the L, the length, makes an angle 45 degrees with the field. What field? It's the magnetic field. So they are telling you L times B, the cross, bukan times, it cross product. L cross product with B is LB sine 45. This is what they are saying. Find the force per unit length exerted by the field on the wire. So it's asking you force per unit length. Now, our equation is just force, which is F equals to ILP sine theta. So if I wanted to make this force per unit length, I just have to move my L to the other side. So I will get force over length, or force per unit length, equals to IB sine theta. Can the theta be still used, can the theta still be 45 degrees? Yes, because we started with this equation. Sine theta is sine 45. I'm just rearranging it to give me F over L. So yes, the angle is similar. The angle tak berubah lah, basically. So I is 5, B is 2 times 10 to the minus 3, and your sine 45. So you will get the answer like that. And since we have this guy is F over L, F is in newtons, L is in meter. So your final answer should include units, which is Newton over meter. Okay. So, okay kot. I think this is quite okay. It's just the equation, just like QVB. Kita dah cakap in length about QVB. It's just applying a similar concept but slightly different parameters. Okay, so kita pula dah. Okay, so kita nak cakap pasal parallel wires. I talked about one wire just now. We talked about F equals to I LB sine theta. Now we have two wires. Okay, so using our right hand rule screw. Yang ni screw because straight wire conductor, coil, solenoid pakai yang screw type. So we have a straight wire conductor over here. I want to know what is my magnetic field. So my I is, macam mana saya nak bagi nampak macam sama? Oh, this is hard. Okay, tak apalah. I is going slightly slanted. So my B is going anti-clockwise, right? Ada gambar kat sini lah. Use your right hand rule lah. You can try it yourself. So what is going on here? We have a magnetic field that is going anti-clockwise. Why is this important? We know that when we have a current, we have a magnetic field. Why is it important to draw this? Okay, when I draw this, I can draw it over here and I can stop. But because I have another wire over here, I need to extend it. So I need to extend my B that it reaches it reaches the other conductor. Why is this important? Because when I draw it like that, I am actually finding out what is the direction of my B on this conductor. So here, my B goes like that. Nampak tak? Walaupun dia melingkar macam ni, but when it goes to my conductor, it is actually in this direction, ke arah into the page. Okay, let me try explaining that again. Okay, so again, we use our right hand screw rule. I draw my magnetic field. Previously, I wasn't bothered about how I drew it. I just know that I need a circle around the wire, right? But now I am bothered to draw it until it reaches the other wire because I want to know what is the direction of B. This is B1, B from current one. So this is B1 and B1 on wire number 2 is, when I reach this, it is going into the page. Macam pelik sikit, but it is going into the page. Into the page, like that. So what happens over here, yang ni dia tak bertembung dengan wire tu kan, so you don't have to care about it. You only have to care at this point when it intersects with the conductor. So when it intersects with the conductor, it is moving into the page. So that is what you need to know. Okay, so my B on this wire is going into the page. So now I have to use my right hand rule yang FIB. I have my I going down. I have my B going into the page. Okay, this is hard. So my F is going to the right. So we used two types of right hand rule here. So I going down, my B is here, my F is here. So down, I should write it like this. So I, F, B. Okay, if you use your hands, you would see that the F is going to the right. Okay, so now you're asking me, doctor, okay, so the straight wire conductor has magnetic field. What about this guy? Doesn't it have the magnetic field? Yes, the answer is yes. Walaupun korang tak tanya, saya jawabkan. So the answer is yes. So what happens there? So let's use a different color for that. So again, using your right hand rule, screw rule, going down, your, what do you call this, magnetic field is going clockwise, right? Clockwise. So if I were to draw it clockwise, is this clockwise? Oh tak, terbalik. This is clockwise. Ya Allah, nak look at arrow pun tak lepas. Okay, so that is my clockwise. So I extend it until it reaches, alamak buruknya, until it reaches my other conductor, the other side. So again, I am going clockwise. When I intersect with the other conductor, which is conductor number 1, I am going into the page, I think. So macam mana saya nak lukis ni? Into the page, macam ni lah saya lukis into the page. At this point, I'm intersecting the conductor into the page. That is my B. B from conductor number 2. This was B from conductor number 1. So now using my right hand rule again, I goes up, B is into the page, my force is to the left. So that is my force. So let me use a different color for that. So B, let's use apa color yang tadi lagi, orange. So B is into the page, I is up, so my F is this way. Okay, betul lah tu kot. Okay, so what happened here? Let's do a mental recap balik. So first of all, I had 2 wires. Both have current, right? When we have current, we immediately know that we will have magnetic field. So I use my screw right hand rule yang I'm using my right hand rule yang screw, right? So the conductor number 1 has B that is going anti-clockwise, and conductor number 2 has B that is going anti-clockwise. Clockwise, sorry. Conductor number 2 clockwise, conductor number 1 anti-clockwise. Okay, I should label it because it's driving me nuts. Okay, so clockwise, anti-clockwise and clockwise. So when we have this magnetic field, the magnetic field from conductor 1 intersects with conductor number 2 and it gives force. The magnetic field from conductor number 2 intersects with conductor number 1 and gives it force, gives it magnetic force. When we use our right hand rule yang screw though, it didn't care about the force. We only talked about I and we talked about B. When we provided the B for the other conductor, and we have I, we have B and we have I, then only we get the force. Okay, when you only have I, you will only think about B. Okay, again, when we have I will try to find out B from the right hand rule screw. Now, when I have I and B, I want to know what is the force. From my right hand rule, FIB. Okay, so this is the chronology lah of things. The I from conductor number 1 gives me B number 1. I number 2 gives me B number 2. B number 1 intersects with conductor number 2. B number 2 intersects with conductor number 1. So what happens here is I1 with B2 gives me FB. I2 and B1 gives me FB. So this is FB1, FB2 lah. Okay, so this is what's going on over here. Is everyone okay so far?
Yes, doctor.
Okay, good. Okay, so this is what I told you earlier. Conductor number 2 has I2, gives me B number 2. So B number 2 is intersect with the conductor number 1, gives me B2 over here. This is I1, gives me FB number 1. Okay, so this is what's going on over here. Okay, so tadi we talked about satu current flowing down, one current flowing up, terbalik, one up going down, one up and one going up. Betul. So now this situation, sama, one up and one going down. So we have F to the right, F to the left. Was it the case just now? F to the left, this is F1, and this is F to the right, F2. So this is our situation here. We found out that we have F to the right and F to the left on each. So this is how it looks like. Oops. So if I were to draw it from the top view, so this is me, no, this is you. Oh my God, I don't know what I'm trying to draw. It's so bad. Okay, so this is my eyes. No, this is your eyes because I don't want to be ugly. So this is your eyes. Okay, so this is from the top view. What I'm seeing is current going out of the page from my angle. So this, my angle, your angle. So this is the paper out of the page or into the page, right? So I'm assuming this page is the paper. Okay, so my eye is going out of the page. Out of the page, I'm seeing the tip of the arrow. And this guy is I2 going into the page. I'm seeing the butt of the arrow. So this is the top view. I get, balik lah pula. Kenapa dia buat terbalik? Top ke tengok pada bawah? Kalau tengok pada bawah, this makes sense. Okay, saya rasa dia tengok pada bawah. So this one is going in, out of the page. Out of the page and into the page. So it's this way. Your view is here. What on earth am I drawing? Oh my god, juling pula. Tidak, sorry. No disrespect to orang yang ada juling. Because it's kind of cute. Okay. So that's your eyes. So this is your view. What you are seeing is one guy is going up, not guy. The current number one is going into the page, away from you, into the page, away from you, and out of the page towards you. So what you're seeing is the butt of the arrow and the dot. So this is what you're seeing over here. Itulah gambar yang dia nak tunjuk sebenarnya. But in situations like this, they will tell you when from which angle you should be drawing the magnetic field or the current. So don't worry about that. Tadi saya confused which part, but they will specify what is the angle that you should be looking at. Okay, so you have X and you have dot, and then you have to draw your B. From this angle, your B is dia terbalik lah kan sebab kita tengok daripada bawah kan. So if I'm trying to look it from down below, I would see clockwise. I would see clockwise, right? Oh, sorry, clockwise. So this is anti-clockwise. Yeah, I'm going to see anti-clockwise. So I'm going to see anti-clockwise here and I'm going to see clockwise here. If from the top, I'm going to see anti-clockwise here and I'm going to see clockwise here. Oh, this is hard for me. Direction ni. Okay. So kena bayangkan sikit lah. Okay. So if you're looking from the top, we talked about AC and clockwise just now because we were looking at from the top. They want you to imagine it if you were looking at from down below. So you have the bullet and the X and your magnetic field is terbalik daripada tu. And because of that, because of the magnetic field that we have, it is going this way. So you know that in the middle, it will go this way. Okay. So you have the bulat-bulat ni kan. Tengah-tengah tu nak fill up. This is how you should fill it up. Look at the direction. This guy is going this way. This guy is going this way. So your net in the middle should be going in the same way but straight. Okay. Tak payah fancy lukis lengkung-lengkung. Just straight line is fine. Okay. What time is it? Okay, 8:30. Okay. Current carrying wires can exert forces on each other. We know this already. First, we talked about the I, we got the B. When we have the B, it exerted on the other wire, we got the I and the B, and we got the force. So now consider the parallel conductors carrying current in the same direction. Just now it was the opposite direction. What happens if it's in the same direction, right? Okay, so now we have I again. First thing, we don't have our B is not provided. Okay, so we have to find out our B using the right hand rule, screw. So I have my I number 1. I want to find out what is B number 1. So using my right hand rule, screw, I will find out that it is anti-clockwise, pretty easy. And then this guy will intersect with the conductor number 2. Conductor number 1. Kenapa lah nak tulis conductor? Tulis wire kan senang. Conductor number 1 and conductor number 2. Okay, B into, when it intersects with the conductor number 2, it is going into the page. So our B is over there. Our B number 1 is over here. Nak kata curang tak juga, tapi dia pergi sana lah. So our I is going up. So using your right hand rule, I going up, B into the page, force to the left. So this is the force that you get from on conductor number 2. On conductor number 2. F, B, on conductor number 2. I am speechless. Why am I calling it conductor? Panggil wire je senang. Okay, so F2 on conductor number 2. So if the wire is flimsy, maksudnya dia tak keras, it would be bent to the left. It would be bent to the left. Tapi benda lah ni kita anggap dia keras je lah. Tak payah nak fikir if it's going to bend or not. Okay, so next one. Diorang nak masuk. Okay, so next one is conductor number 2. We want to find out what is our B number 2. So from I number 2, we get our B number 2. Sekejap, saya lupa nak lukis conclusion kepada benda Allah ni. Do I2 plus B1, I should say N, gets us FB number 2. Force on conductor number 2. This is conductor wire number 1, wire number 2. Okay, so this is wire number 2. I get my B2. Use my right hand rule. Again, same thing, anti-clockwise. Okay, so now it's anti-clockwise, right? So ada effect ke kalau sama? Yes, ada effect juga. So it's anti-clockwise, extended. So anti-clockwise goes this way. So my magnetic field, when it intersects with the conductor number 1, it's going out of the page. So it's B2. It's out of the page. So I have out of the page B, out of the page B, I is up, my force is to the right. I1, and this is my force number 1. So I1 and B2 gives me FB number 1, the force on wire number 1. This is wire 1. Okay, is everyone following me so far? Is this hard or is this okay? Any questions? So everyone's okay with this, okay?
Okay.
Right. Jangan buat. Right hand rule, FIB. Okay. Yay, we found out correctly. So magnetic field going anti-clockwise intersects gives me out of the page B, right? And then I is this way, so you get your force to the right. So we got it. Okay, so drawing again. Ini angle apa? Okay, so tell me if are we viewing this guy from the top or from the bottom?
From the top.
From the top, correct. So now dia nak tengok from the top pula, ngada-ngada kan? So here, what I'm seeing, this is my eyes. No, this is your eyes. So I'm seeing the current flowing out of the page. Out of the page. Okay, so I'm seeing the bullets. So we draw sama je macam ni. So it's similar. So this was anti-clockwise, anti-clockwise. This is also AC, AC. If I'm viewing it from down here, it would become clockwise. Dia terbalik lah. Okay. Right. Okay, so we talked about the theory. I mean, like using the right hand rule and stuff, right? What happens when we have I, we got B. When we have I and B, we get F. Now it's time to calculate as usual. So the magnetic field produced due to the current in wire 1 at position of wire 2. So we are calculating for B1. The B1 is from this guy, right? This is our B1. This is B2. So we want to calculate what is B1 exerted on I2. I should probably draw it at a different place. So B1 extends to this guy. Okay. And my B2 extends to this other guy. Anti-clockwise. Anti-clockwise rupa dia macam ni. Betul. Okay, so clockwise, this is B2. Okay, so I want to calculate what is B1 on I2 because remember I2 with B1 gives me the force. I'm interested to know what is the force, so I need to know what is B1. So B1 is mu naught I over 2 pi r. It's the straight wire conductor punya equation. Remember B equals to mu naught I over 2 pi r. But this time the r is the distance of conductor number 1 to conductor number 2. This is the R. Okay, remember this equation gives you the magnetic field from the wire to point R. So if guys don't remember, I'm going to tell you. So this is point R. So this is the B that it is calculating for. If my R extends, then this is my R. If I wanted to know what is the B over here, it would be slightly smaller. This is B naught, this is B number 1, let's say. So B1 would be smaller than B naught because the closer you are to the straight wire conductor, the stronger your B is. So this is what we discussed early on in the chapter. We talked about finding the B, and the B was dependent on the radius that we are trying to find. Kedudukan dia lah, kedudukan. So the further away you are from the straight wire conductor, lagi lemah the magnetic field. So this was the equation that we talked about earlier. So it was mu naught I over 2 pi r. The r is the distance that you want to find out what the B is. Okay, tak kisah distance berapa pun. So now the distance that we are interested in is of course the distance when it intersects with the second conductor. So it is just D. D is the distance between I1 and I2. I want to know what is B over here. So my R should be the D, okay, the distance. So mu naught I1 over 2 pi D, or you can just say 2 pi R, sama je. As long as you know what it means, you can use either equation, it's fine. Okay. And then the magnetic force on wire 2 of length L2 and current I1. So we had another equation which is F equals to ILB that we learned earlier. This was the force on a straight wire. This is not the equation for charge. This is equation untuk length of wire, right? The force on a length of wire. So ILB sine theta. Now that we know what is our B1, okay, this is B1. So our B on conductor number 2 is I2 length conductor number 2 B1 sine theta. Okay, in this case, your sine theta is always 90 degrees lah because it's parallel. Magnetic field is always 90 degrees. This one is 90 degrees. So you can ignore the sine 90 sebenarnya. Let me just ignore it here. Okay, untuk straight parallel wire, you can ignore the sine 90 because it's always, the B is always 90 degrees to the I. So you don't have to care about it. Or you can just say sine 90, boleh juga. It means the same thing. Okay, so what I'm trying to say here is that the force on conductor number 2 is dependent on B1. We know this already. But your I is from conductor number 2. Your length is conductor number 2. Benda ala B ni je from 1. Okay, we talk about this. I2 plus N B1 gives me F2. So it will always refer to the conductor number, the current. Okay, B je yang akan terbalik. So kalau current number 2, length number 2, you will use B number 1. If current number 1, length number 1, you will use B number 2 sebab B datang daripada orang lain. B always datang dari orang lain in this situation. Okay, so this is something that is very important and I don't want you to mess up, okay? So always, the B is always the kambing hitam lah. Did I use that peribahasa correctly? Yes, kambing hitam. So B1 over here, kalau kita tengah cakap pasal F1, it will become B2, I1, L1. Again, our B is the oddball. Okay. Okay, same thing. You can just remember it this way. I think this is much ILB. So this is 1, 1, 1, 2. So B, you know the equation for B. B is mu naught I. This is number 2, right? So mu naught I2 over 2 pi D or 2 pi R. So B nombor 2 ni, sorry B nombor 2 pula. Magnetic field 2 is from I2. Okay? Magnetic field we get from the right hand screw rule. I2 gives us B2. This B2 intersects with I1, which is used in this equation. So we are trying to find the force on conductor number 1. Dia macam confusing sikit, but nanti kita buat exercise nanti, okay kot, I think it will be okay. Alright, so the force per unit length is given by, same thing, same equation. Wait, it's not. Apa ni? Sekejap, defining Ampere. Okay. So F equals to ILP. Dia nak rearrange jadi F over L. So I'm left with IB. So B is mu naught I over, sorry, this is number 2. Let's say this is number 1. So this is 2, I1, mu naught I over 2 pi D. Okay, so this is how the equation is derived. So I1, I2, mu naught over 2 pi over D. Sama lah, rearrange je. Okay, so this is how you get the I1, I2. Okay, so this is talking about F2. So you know that I1 is from B. Okay, itu je. So this is just expansion. You don't have to be, tak payah panik lah, ni expand je. So the force between parallel conductors is used to define Ampere. Okay, if two long parallel wires 1 meter apart, so D is 1 meter. D is 1 meter and carry the same current. I1 and I2 is the same, and the magnitude of magnetic force per unit length is this guy. Then the current is defined to be as 1 ampere. Okay, I don't know how to simplify that. Let's see. F over force per unit length, L, mu naught, 2 pi. This is a constant. Alamak. Battery saya nak mati. Sekejap. Okay, that was close. Mu naught 2 pi. Sorry. I should be the same. So I, so it's I squared. And your P and the magnitude of magnetic force per unit length is, then the current is defined as 1A. Oh, okay. So it's saying F equals, F over L is 2 times 10 to the minus 7. Jika force per unit length is 2 times 10 to the minus 7. So we have this equation, mu naught over 2 pi I squared over D, because I is the same. So using this definition, you can say, okay, if all of this is equal to 2 times 10 to the minus 7, then the I is simply 1. Okay, the D pun satu juga. The D is also 1. So D is equal to 1 and I is also equal to 1. That is what this equation is telling us. So okay, again, I'm going to repeat myself. If F over L is equal to 2 times 10 to the minus 7, then this equation is equal, and our D is equal to 1, then our I for the current, sorry, I for the current, our I flowing in the wire is equal to 1 ampere. It's just that. So equation equals to 2 times 10 to the minus 7, D equals to 1, I equals to 1. Okay, so that, I think that is quite simplified. Okay, so now, okay, now we have forces between two current loops. Just now we talked about parallel wires. I know this is quite heavy, but please bear with me. Pasal torque ni kita akan belajar next class. So this one habiskan jap. Okay, so now we have this coil and this is a solenoid. So I have a coil. If I use my right hand rule, my thumb should point towards the north, or my fingers should point in the direction of the current. It depends on what they give you. So in this case, they give you the current lah, I guess. They give you the current, it goes like this. Apa ni? Anti-clockwise. So this is the north that I'm getting. So the north is to the left. So I have south over here. So this is north, this is south. I shouldn't draw the arrow there. So this is the arrow north. And then same thing, I have the arrow north. So north, so if this guy is north over here, this is south. North over here, this is south. So north with south will attract. Tu je nak cakap. And then when we have a coil that is carrying current down here, going this way, north to the left. Okay, I'm using my right hand rule screw. And then this guy, it has the opposite direction of current. So current is going towards me. My finger is going towards me. So my thumb pointing to the right. So this is my north. So here we have south with south, they will repel. So this is when you have two coils, you flow current depending on the north and the south, they will either attract or repel. So you can do that. That's a nice experiment to do if you have the time. And then this is for coils. And then you have solenoids. Of course, you know solenoids, the magnetic field inside is super strong, but the magnetic field outside is weak. So when we have a super strong magnetic field inside the coil, it behaves like a magnet as well. So here we have the direction this way. Betul tak? We talked about if anti-clockwise, it should be north. Let's see if it's right. Anti, north, and clockwise should be clockwise, S, right? South. So anti-clockwise should be north, clockwise should be south. Let's see. This guy is looking like, what does this guy look like? Dia nampak macam anti-clockwise. So it's the north. Betul. So if this guy is the north, I can just say, okay, this is the south. I don't have to care anymore. And then this guy is anti-clockwise. So it is N. And if this is N, this is south. So again, south with north will attract. Okay, same thing here. My current is flowing anti-clockwise over here. So this is north, this is south. My current is flowing clockwise over here. Clockwise is south. So south with south, repel. Okay, that's another way to know the north and south apart from using your right hand rule. Okay. Kejap So we have ikut soalan and then it's start. Okay, so let's do this one and we are done for class. So I'm going to assign, of course. So let me assign this to Christina, because that's the first name that I saw. So I want Christina to do this question. Tangkap gambar, share to on WhatsApp. Can you do that, Christina? Is Christina there? Boleh So Christina will be doing A. Nurul ni siapa Nurul? Nurul apa
Nurul Hikmah.
Oh, Nurul Hikmah. Okay, Hikmah B. And then who is my lucky person today? One Fatihah. Hari ni semua girls. Next time it's all boys. Cik, tak adalah. Tak ada competition pun. Okay, so Christina, Hikmah, Fatihah buat ABC. And then please share it with class. I am going to share this question in the WhatsApp group as well. So everyone can try. Then, kita tengoklah jawapan macam mana Lemak ni dah kasi jawapan pula. Okay, tak apa. So I think that's it for class. Or do we want to do it together? Do you guys want to do it together? Or assigning is fine? Okay, semua orang dah tak larat dah nak pingsan. Okay, so let's just end class here. So don't forget your attendance on Putra Blast. I will be waiting for Christina, Hikmah, Fatihah to share on WhatsApp. I will be sharing this question as well and the answer, not the answer scheme. And that's it. Okay, so take care everyone. I will see you next week and bye-bye. That's it.
Doktor,
Thank you, Doktor.
Yes.
Doktor.
Ada orang tanya soalan?
tanya,
Aha.
kalau untuk I1 dengan I2 kita vice versakan dia punya arah boleh
Kalau apa?
I1 dengan I2 punya direction kita terbalikkan.
Boleh?
I1
boleh.
boleh.
Because dia tak kasih
Okay.
gambar kan? Boleh.
Okay, thank you Doktor.
Welcome. Bye-bye.
Thank you,
Thank you,
Doctor.
Doktor.
Thank you, Doctor.
Thank you, Doktor.
Thank you, Doctor.
Semua nak pengsan. Tanya soalan tak jawab.
Thank you Doktor.
Balik laju je. Okay, bye. Stop sharing. Recording lagi. Stop recording.